Welcome to this demonstration of Unified Workflow Tools, File Copy and Link Mode. We'll start by installing Conda. This is optional if you have an existing Conda installation that you can use. We'll then install uwtools. It's possible to install into an existing Conda environment, but for the purposes of this demo, we'll create a new environment specifically for uwtools. We'll use the MiniForge variant of Conda provided by the CondaForge project in their MiniForge GitHub repo. From the repo's main page, we can scroll down to the releases and select the latest release. At the bottom of the list of available assets, we see installers for several platforms. I'm running Linux on Apple Silicon and a virtual machine, so I'll select the installer for the AArch64 architecture. In my terminal, I'll download the installer and then run the installer with bash, providing the command line options -b for batch to avoid prompts, and p for prefix to specify the installation location, which will be Conda in the current directory. When the installation is complete, I can activate Conda by sourcing conda/etc/profile.d/conda.sh and running conda activate. To create my uwtools Conda environment, I can now type conda create -y to suppress prompts, -n uwtools to name the environment, -c ufs-community for the channel that contains the uwtools package, and -c condaforge to obtain packages from the condaforge channel, which uwtools requires. Now I can give the name of the package uwtools, which will install it and its prerequisites. If I don't provide a version number, I'll get the latest release, which is what I want in this case. Now I can activate my newly created environment and verify that I have access to the UW CLI. We'll start with basic usage of the tool, copying and linking files from a source to a destination directory, initially demoing the dry run feature. Let's look first at our input data. Under /temp/data, we see what appear to be GFS forecast files from 2 cycles of a recent date and a file called initial.nml, which presumably contains Fortran name lists. Now let's look at the file config.yaml, which will be the configuration file used to drive uwtools. The contents represent a mapping from destination files in the target directory to the paths to the source files that are to be copied or linked. We can specify additional directory structure in the destination, and uwtools will create the directories as needed. We can also perform renames of files by changing the names. In this case, we'd like to copy the initial.nml file into the target directory with the name final.nml and copy 2 of the 4 forecast files into subdirectories of the target directory, where each file has the name gfs.ics. Let's look at the CLI help for the file copy mode. I'll type uw file copy --help. We can see that there's a single required argument, which is the path to the target directory. There's also an optional argument to specify the path to the config file. If that's not specified, then the config will be read from standard in. We also have an optional argument to specify dry run mode. When that's used, uwtools will avoid making any changes on disk and simply show what would have been done. Now let's do our dry run test. I'll run uw file copy --target dir, and we'll use target in the current directory as our destination, --config file config.yaml, and finally I'll request dry run treatment. We see that uwtools interpreted our configuration file correctly and wanted to copy initial.nml to final.nml in the target directory. However, because we're running in dry run mode, that action was skipped. Similarly, for the forecast files, they were both located and reported, but also skipped. As a side note, let's see what happens when one of our source path names is incorrect. I'm going to change the second forecast file to point to a non-existent subdirectory, and then rerun my uw file copy command again. In this case, we can see that uw flags the non-existent file with a warning. Let's now correct the error in our configuration file. And rerun our uw file copy, but this time without the dry run. This time we see all three files are in their ready state, meaning that they were successfully copied to the target directory, the namelist file and the two forecast files. All the work is ready, and if we look at the target directory, we can see that everything is as we expect. The final.nml file and the two gfs.ics files in their respective subdirectories. To link instead of copy files, we can remove our target directory and then rerun our uw command, changing the copy action to link. uw runs to completion, and then if we view our target directory, we can see that we have symbolic links instead of the previous file copies. Now let's look at a more advanced use case. We're going to edit our configuration so that our files are specified in two separate lists, one of files to copy and one of files to link. We're going to take a repeated prefix path and dry it out as a separate YAML variable that we can then reference. And we're going to parameterize the entire configuration via an environment variable. Finally, we'll use the API to perform the same action we just performed with the CLI. Let's take a look at our updated config. We've added an arbitrarily named top-level key called files, and under it, arbitrarily named keys copy and link. We're going to use copy to refer to files that we'd like copied into the target directory, in this case the Fortran namelist file. And we're going to use link to refer to files we want symlinked into the target directory, in this case the two GFS forecast files. The two GFS files share a common prefix path /temp/data, which here has been factored out as the value of a new and arbitrarily named top-level base-dir key. This key is then referenced in Jinja expressions in the source path values. We'd like to be able to use this configuration for multiple forecast cycles by referring to an environment variable providing the year, month, date cycle information. We can do this by referencing the YYYYMMDD environment variable and piping it through the custom Jinja filter env, which will interpolate in the current value of the environment variable to complete the path name. To test our updated config, let's first remove our old target directory. Then we'll rerun the uw file tool, copy action. Since our list of files to copy are no longer at the top of the config, we need to specify the YAML keys leading to the block in question. In our case, the keys are files and copy. Then, to obtain our symbolic links, we'll rerun the tool, link action, and change our keys from files copy to files link. Since our symlink source paths in the config reference an environment variable, we'll need to set that here. With that set, we can execute uw, and our links are created. Examining our new target directory, we see the expected copies and symlinks. To demonstrate API access to the file tool, let's first remove our old target directory, then enter the Python REPL. From the uwtools.api.file module, we'll import the copy and link functions. Looking at the help on the copy function, we see the function signature. We can invoke copy by supplying the target directory, the path to the YAML config file, and the keys leading to the block of files to be copied. Before we can invoke the link function, we need to import the OS package and then set our year, month, date environment variable to the expected value. With that done, we can invoke link and update our keys to point to files link. We can now exit the REPL and take a look at our target directory, which contains the expected copies and symlinks. Thank you for watching. We hope you found this useful. Please feel free to visit our GitHub repo or view our documentation online.